How's it going, guys? Today we're going to be going over number complement. This is a question that's commonly asked by Cloudera. And so the problem description says, given a positive integer, output its complement number. The complement strategy is to flip the bits of its binary representation. So just as quick notes, it says the given integer is guaranteed to fit within the range of a 32-bit signed integer, and you could assume no leading 0 bit in the integer's binary representation. So as a quick example, if we're given the input 5, we want to output 2. And the reason for that is the binary representation of 5 is 1, 0, 1 with no leading 0 bits. And this complement, or flipping all the bits, would be 0, 1, 0, and therefore that corresponds to 2 in binary. So this really comes down to a couple things, right? So we want to go through the binary representation of the number we're given, and we want to check all of its bits individually and flip its bits. So that probably tells us that we're going to need a while loop to go through the number. And what we learned from a couple of my other videos is that we can go through this number, and a good way to check if the least significant bit, so the bit to the furthest, all the way to the right basically, is 1 or 0, we can check if the number is even or odd. So we can take modulo 2, and that will tell us if the number is even or odd. And then we can kind of pair that with the bitwise operation XOR, and that will give us whether or not we should or should not flip that bit essentially. So XOR will return, if we XOR it with 1, that will basically give us the number for the complement, and then that just leaves the basically like associating a power with the binary, like whatever digit we're on in the binary, so we just have to keep track of a power. So we can have a loop, go through all the numbers in its binary representation, use that XOR kind of strategy that I talked about, and every time we can just shift our number so that we deal with the next bit in its binary representation, and we can multiply the power that we have to basically like how much we need to add to our result to come up with the correct complement number. So if that didn't make sense, we'll go through it now. So we said we need a number to return, so we'll have something called result, which will just start at 0 because we haven't added anything to it. Then we need a power, right? So we'll say int power equals 1, and that's just going to start at 1 because 2 to the 0 is 1. And now we need our while loop, so we'll say while num is greater than 0. So while we haven't gone through all the bits in its binary representation, we still need to continue. And we said we will add to our result. We want to do num mod 2, so that will give us the last bit in its binary representation, and we'll XOR it with 1, so that will flip the bit correctly, and then we want to multiply it by whatever our power is. So that will take care of populating our result, and then the next things we need to do are change our power, right? So if we do power shift by 1, that's really the same as multiplying by 2. And then we need to change our number that we're going through so that we actually terminate in our loop. And we evaluate the next bit for the next iteration. So we can say num shift equals 1. And that's the same as dividing by 2. And that will basically truncate the bit that we just evaluated. And so by the end of this loop here, we should have actually correctly populated result. And all we should have to do is return it. So we'll say return result. And that should do it. Awesome, and it does. So if you guys have any questions, be sure to leave it in the comments. If this was helpful, be sure to subscribe or release a video every day, and I will see you guys next time.